Okay, guys, today's vodcast is going to be a quick review of what we need to fix before your test tomorrow. So I do want to let you know, because I wasn't able to get those vodcasts up for technical reasons, we will not be covering predicting products of double replacement reactions or net ionic charge on the exam tomorrow. Those questions have been eliminated from the test. So it is good news for you guys, but you will still have your test tomorrow. So what I want to cover today is what am I doing wrong and how can I fix it before the test tomorrow. What I've done is I've taken a few of your test questions or your quiz questions from the second quiz, and I'm going to take a look at what you guys are doing wrong on these problems and what you can do to fix them. So we are going to jump to my desktop where I've taken a picture of a few quizzes so that I can point out to you what some of the problems with this are. Okay, what some of the problems, common problems with the quizzes were. So here you'll notice that this person has completed the problem. I'm going to look here at number 2. So, one second. I can give myself a red pen. And I'm going to take a look here at number 2, where we have C2H4 plus O2, which was given to you by the problem. So, thankfully, they got that part right. And then you have your end products here of a combustion reaction. Now, first they put that it was a single replacement, which does make sense if you look at, there's one element here and there's 2 elements here. But the problem is that this person didn't pay attention to what that compound is and what this compound is. Anytime you have a hydrocarbon, that is something that has hydrogens and carbons, so hydrogens and carbons, and you have an oxygen, this is actually a combustion reaction. Okay, so the end products of a combustion reaction are always the same. They got the water part right, but this carbon should be CO2. And if you don't get the products right, of course you're not going to get the balancing right either, because you don't have the right elements on this side. So this is a combustion reaction. Please remember, anytime you have a hydrocarbon and an oxygen, what you have is a combustion reaction, and the products are always CO2 and H2O. Okay? Okay, I would like to use this next example as a good example for why you definitely need to pay attention to what you're doing in the problem. And what I'm looking at is here. This is a single replacement reaction, and what you have here is aluminum and zinc chloride. And what they put on the other side was zinc chloride and aluminum. Now, of course, what they forgot to do here is to do the replacement part of this single replacement reaction and actually put the aluminum with the chlorine. Okay? And there was another problem with this quiz that I wanted to point out, and that was the decomposition of aluminum oxide. With the aluminum oxide, what they did was they just took the number of aluminums and took it over, and they took the number of oxygens and took it over. And what they forgot was that, of course, you balance last. And instead of taking over 3 oxygens, oxygen is a diatomic, so it should always be O2 when it's by itself. So it should be aluminum and oxygen, and you need 2 of those. Now, in order to make this balance, of course, you're going to need to put 2 over here, 3 here, and 4 here. Okay? And of course I skipped all of the count, compare, change, and check, but we counted our aluminums over here. Now you have 4 aluminums on this side and 6 oxygens on this side. You have 4 aluminums on this side and 6 oxygens on this side. Okay, so don't forget your diatomic molecules. Those are going to make or break you on the test tomorrow. And here is an example of a question that looks right, and the person probably thought, oh, my bad. Okay. All right, sorry, I had to get into drawing mode here. This is an example of a question that probably people thought looked correct, but was in fact incorrect, and I'm going to point out why. This is KCl, this is potassium chloride, aluminum hydroxide, which is correct because that was given to you by the problem. They did get the type correct, it is a double replacement, and they got the formula correct. So they put the 3 Cl's with the Al, of course, because aluminum has the +3 charge and the Cl has a -1 charge. So when you put the two of them together, you do need 3 chlorines. That is actually correct. What they forgot to do was the last step, which is to balance. Okay? Don't forget, at the end, you need to make sure that your number of atoms is equal on both sides. So you need to make sure that if you have 1 potassium over here, you have 1 potassium over here. The potassiums are fine. The chlorines, however, are not. And so you do need to modify this to make your chlorines correct. And of course, if you add a 3 here and a 3 here, you will have a balanced equation. So don't forget the last step of balancing. She got her formulas right, and she forgot to balance. So that was what was wrong with this particular problem. Okay. All right, on this one, the type was, of course, correct. There's aluminum and oxygen, and you have Al2, which is incorrect because aluminum is not on our list of diatomics. Please remember that your diatomics can be remembered with have no fear of ice cold CLBR. Oh, ice cold beer. Have no fear of ice cold beer. If it's not on that list, it doesn't need a 2 after the end of it when it's by itself. So aluminum actually can exist by itself, and oxygen, of course, is on the list, and so it's a diatomic, so having O3 is not the answer. Having O2 is. Now, of course, this means that this equation is not balanced, because now you have 2 Als over here and 1 Al over here, so this needs at least a 2. Okay, so we have 2 aluminums here, 2 aluminums here. But then we have a problem because we have 3 oxygens and 2 oxygens. So we need to have an even number of oxygens, put a 2 here, which changes our number of aluminums to 4. It changes our number of oxygens to 6. And to get 6 oxygens over here, we put a 3. Then we need to change that 2 to a 4. So we end up with 2, 4, 3 as our balanced equation. So don't forget, you need the formulas right and you need to balance it right. But those were the problems with that question there. Okay, next up I'm going to be dealing with a case of someone who obviously kind of got stuck at the very beginning and didn't know where to go next. And so what they did was they tried to do the types of reactions first, and then they didn't know where to go from there. And this is actually quite common, and in many cases you have a situation where you don't know where to go next. And so with for magnesium chloride, for example, and aluminum and zinc chloride, if you know that you have 2 things here, okay, and let me change my marker color, and you have 1 thing here, okay, you know that one of these is going to come in and replace one of those, okay, and this is going to be a substitution, not a synthesis. And the reason it's not a synthesis is you don't have 2 things that are by themselves, okay, so you have 1 thing coming in to replace one of a pair of things, and so this makes it a single replacement, okay. And single because one of these things is single, and you're only replacing 1 thing, okay? So that's how you can tell that it's a single replacement. And where you go from there is you want to find the elements that have the same charge, and that is the 2 positive ions here. You have aluminum with +3 and zinc with +2. And that is what is going to be replaced, is your positive charges in this case. Of course, if this aluminum were to have a negative charge, it would be replacing this negative ion over here. Okay? On this instance, and I actually corrected this on this test, okay, they didn't miss 15 points because they had the type correct. what they didn't have is products. Okay, so for magnesium chlorine, magnesium chloride, okay, you have magnesium and you have chlorine. So you should at least be able to give products of decomposition, okay, which is why the decombustion, okay, should be decomp, right? Decomposition. So you have your magnesium and you have your chlorine. This should have been a fairly easy one because it was already balanced if you just separated the magnesium and the chlorine into two separate things, okay? The last one here I also want to go over was potassium chloride, which of course is two things, and your aluminum hydroxide, which again is two things. So anytime you have two things and two things, you are looking at putting your positive with your negative, putting your positive with your negative, and that means you're not substituting only one thing, but you're substituting two, which would make it a double replacement reaction. Okay. All right. And with that double replacement reaction, it should be fairly simple to put together your products, which would be, of course, would be KOH and plus aluminum chloride. Okay, this next problem that we had a few mistakes, and I wanted to go over them. Again, you have your combustion reaction here with, they're treating it like a synthesis and putting both of these things together. Also, here was kind of a, I think, excuse that, that's my daughter. Please. Okay, and you have iron nitrate here and iron nitrate over here. Now the problem is the CaCl completely went away, so there were no products, there wasn't a product over here on the other side. Of course, for aluminum and aluminum oxide, you have the elements right, but the number here should be a coefficient. And of course, from the last one, we saw that the actual balancing should be 2 and 4 and 3. So the balancing on this one was wrong, but the elements were correct. So, of course, you have one of the problems here was that sodium is Na, not in, and that caused kind of the whole problem to be wrong. So on this one also, our final answer here was what is wrong with this formula. And of course what's wrong with this formula is sodium is positive and magnesium is also positive and fluorine is negative. And these two charges would repel each other. Okay, so the charges on this answer, the charges of the elements don't add up to what they were written down, isn't exactly clear that these two charges would repel each other. So positive and positive don't mix. And so you can't have a compound that has two positive charges. Okay. All right, and I wanted to end with an example of a very good answer, and I just wrote all over her answer. I wanted to give an example of a very amazing answer because this answer was both complete and 100% correct. This was magnesium fluoride plus sodium leads not to fluorine and sodium magnesium, which doesn't happen. So her answer was, what's wrong with this reaction is that there are two metals paired together. Sodium has a +1 charge and magnesium has a +2. In order to make this a correct single replacement reaction, you must have the sodium flip with the magnesium in the beginning so that it's paired with F2. Your outcome should have been NaF. And so she included everything that I wanted to see in the answer and actually got a +5 points for having a very complete and thorough answer. So congratulations there. Now I'm going to put up another video here in a few moments and cover a bit more about the quiz and what you can expect to see on your test tomorrow. So go on to part 2, and I'll have more information there.